Today I'm going to give you a teardown of the partial Unitron clock drive that I received. This obviously has been tampered with many times and very likely was incomplete from the get-go. I'm supposing it was probably leftover parts left over at Unitron, or perhaps somebody broke this at some point. Anyway, it's only partial, and I'm going to attempt to restore it or rehabilitate it in some way and make it useful. First of all, let me show you how this thing works just as I received it. And there are quite a few screws missing. Obviously, people have gone in and cannibalized some of the parts and screws and so forth. That's possibly what happened with the 3-ball governor also. Hard to say. Anyhow, I wanted to show you what it looks like. This is very interesting. I think you will find this to be quite interesting. It's got a ratcheting mechanism, and I'm pretty sure you can hear that. The ratcheting mechanism allows this to wind up the cable. Now normally with the cable on it there'd be a pretty good of downward pressure. And you can see I'm just exerting a little bit of hand pressure here and causing the mechanism to turn. You can hear it whirring pretty good. And you can see that the gear train here has the effect of simply acting as an escapement to slow this down. This here would connect essentially to the telescope, so it's going to have to turn at some fairly slow RPM, much slower than I'm turning it here. And this mechanism has the purpose of governing how slowly that turns by this. This is called a crown gear, and there's a pinion there hooked to the governor, and that governor spins, and you can change the rate at which that governor spins through the friction device here. I'll take that apart and show it to you. And that's how the whole thing works. It's really pretty cool, pretty simple in principle. So let me take this apart. And this thing was not at all complete. Some of the screws are incomplete or wrong. These are, surprisingly enough, these are 440. That's a 440 screw, common. I can buy this over at the hardware store. I can't buy quite what Unitron had for it, but I can get something real darn close to that. That's a 440. Here's the mechanism, and let's put that aside. This, of course, the crank just comes right off like so. And I've already taken some of the screws out. Some of the screws are already missing. A lot of the parts here on this thing have been used for something else. I've got several pieces I need to remove here. Several screws. Those are elegant screws. You're not going to quite find anything. I probably could make something pretty similar to that. It would take a long time to make that though on my lathe. These are 1024. That's a 1024. I was amazed to discover that those were good old regular US threads. These screws are also tricky. They have a tiny little taper on them. It's a 440 screw, but it's a tiny little taper. Hard to replicate that. Oh, I think I'll leave that on for now. It's not really necessary for this teardown. When I pull that off though, this makes this, you can see there's some nice ball bearings in this housing. Very straightforward. A little greasy, but no big deal. Now this thing should be, well, I have to remove this one. There are several other missing screws here. So now at that point, I should be able to pull this plate off. And let's see how well that works. go. Okay, and you can see why I didn't necessarily need to remove this. This is just a kind of a platform for the friction device to rest on. So there we have that piece, and now we have exposed the innards of this device. This is where it gets a little tricky. I'm not an experienced clock maker, so I have not done very much of this kind of thing. It doesn't seem to be all that complicated. The tricky part is making sure that you can get it back together again. And actually, this is about my second or third time doing this, so I've already done that a couple of times to make sure I know how to do that. Here I have another little difficulty. I put these in. That's a 440 there. And the reason I did that was because they were missing. And I'll try and find something that's a little more authentic looking for that. I pull this part apart. Now, that piece looks like so. And at this point, I've got several gears, kind of gear systems and pinions and stuff floating around in there. And it would be easy to just start pulling stuff out of here and not be able to get it back together again. So I'm trying to avoid that. That's one of the reasons for making this video. It's not just for your edification, although I don't mind doing that. It's also so I can make sure that I do it properly when I get it back together. Get messed up. I'm also taking still pictures as I go along the way. Some of these little bits here, this one here, this support is tricky because it's actually been notched to allow that gear to go in there. So you got to make sure you get those in the right place, and I will make sure I do that. And at this point, I can now start pulling gears out of here. My purpose is to get to this crown gear so that I can figure out what size pinion I need. Maybe I can replace that. I'm hoping I don't have to make it. I am learning how to make gears now, but I'd rather just replace that with something I can buy online or from Boston Gear or whatever. Anyhow, let me show you how this now works. This can now come right out. So there we have just a pinion and a gear. And here's what I was looking for, is this part right here. And this is a very nice little elegant piece. I have to try and match that to an appropriate pinion. I'm guessing that if it's probably some sort of a standard American sized gear, not metric, but I'll find out. I have to measure it and find out. And I think that's as far as I'm going to take it down, at least at this point. There's no need for me to go much further. I can certainly see what I need to do here. Measure that gear. It's fairly simple even for me to put this back together. How cool is that? Alright, stay tuned and I'll let you know what happens.